Welcome to the Intermolecular Forces lesson. There are three types of intermolecular forces: London dispersion forces, dipole-dipole, and you also have hydrogen bonding. Intermolecular forces are forces that connect between other types of molecules. They aren't bonds in between another element or another. So like this would be an intramolecular force. This wouldn't be intermolecular. Intermolecular would be something along the lines of this, where it's sort of like connecting the different pieces of a molecule. Water is a common example of hydrogen bonding, but not to be confused, this is the intermolecular force part. This is the intermolecular force, and we would call that hydrogen bonding, just because of the fact that hydrogen bonds with either nitrogen, oxygen, fluorine. Either of the three would be considered a hydrogen bond. So as long as the molecule is binding to a nitrogen, oxygen, or a fluorine via hydrogen. So let's go back over to London dispersion forces. London dispersion forces are going to be weak forces, and so these forces are easily broken apart. And these forces are also in every type of molecule. So everything has a London dispersion force, but we like to just call this nonpolar. So it doesn't necessarily have to, it can't be polar, it has to be nonpolar. But dipole-dipole is polar, and hydrogen bonding is obviously polar. So this would be a high boiling point / melting, just because it has those strong bonds. Lowest boiling points / melting. And then this dipole-dipole would just be in between each other. So say we had something a bit different in terms of this. This would be separate. So say an HCl. So when you have HCl, these two are separate from each other, and this would be considered to be polar. So as long as they are polar, it's going to be a dipole-dipole. because if it's polar but it doesn't have anything in regards to nitrogen, oxygen, or fluorine in relation to hydrogen, it's not going to be dipole-dipole. So the one time where London dispersion forces can be tricky is when the bigger the London dispersion, bigger the London dispersion force, the stronger it is. So in this sort of chain, if you have more of these bonds, it's going to be stronger. So if I compare these two, say this is my compound A, my compound B has a bit more. This was going to be more polarizable, or just has more electrons, so it's just more difficult to break those bonds. So that's a good example of London dispersion forces in the case of more polarizable. So it just has more electrons. So that's when you can tell which of these LDFs would be stronger. These bonds will have London dispersion forces. So LDF and then LDF. As well as hydrogen bonding also has dipole. Thank you for watching this video, and I'll see you in the next one.